Morning students, myself Vijay Shankar from Electronics and Communication Engineering Department, Chibrol Engineering College, Chibrol. Today also we are going to discuss about the inverse Fourier transform and the Fourier transform examples. So in the last class, we already discussed about this gate function, the Fourier transformation, and for this, the Fourier transform, we got some ambiguity is there. To get it is x of j omega is equal to 2 by omega square b minus a cos omega a minus cos omega b. It's a little bit the confusion we got here. So I will clarify this in the today's class. See, we got the x of t is equal to t plus b by b minus a in the range of minus b to minus a, and 1 with the range of minus a to a, and a t minus b by a minus b in the range of a to b. Okay, my dear friends. So now, we solve this equation. X of omega is equal to, we have integral minus b to minus a. The first term is t plus b, t plus b by b minus a into e power minus j omega t dt plus the second term is minus a to a, 1 with this x of t, my dear friends, x of t, the t plus b by b minus a line equation, e power minus j omega t dt plus, and the third one a to b t minus b by a minus b, is it x of t we got e power minus j omega t dt. Okay, my dear students. These are actual Fourier transformation of the signals x of t when the range of minus a to b, minus b to minus a, t plus b by b minus a, and minus a to a is a 1, and a to b the t minus b by the a minus b. The simple simplification only. Yesterday we did something wrong is there in the simplification. Now you can see, split this at the two parts. The integral minus b to minus a, the t by b minus a e power minus j omega t dt, and the second term plus, I'm writing the outside, my dear students, because it's a constant, b by b minus a, the second term, integral minus b to minus a e power minus j omega t dt, plus, here the third term is there, we'll get minus a to a e power minus j omega t dt plus, and this term is also, you can split it the two parts, integral a to b t by a minus b e power minus j omega t dt. Here it is a minus term is there, my dear students, minus, or I am writing the plus integral a to b is a term minus b by a minus b e power minus j omega t dt. Okay. Now we got the totally the 5 integrals. After splitting off, the first term is a 2 and the last term is also the 2 functions. Now in this 1 by b minus a is a constant, my dear students. 1 by b minus a is a constant. Now apply the t into e power minus j omega t dt as a UV rule. As a UV rule, the t into e power minus j omega t dt by minus j omega with the limitations of minus b to minus a minus and integral of the t is a derivative you have to apply here, e power minus j omega t by j omega. See, I am directly applying here with the derivative of 1 and also the integral. I am removing this here integral value, not the value, integral. 2 times I am applying the derivative. Okay. With the 2 times, so one time it is a j omega, another time it is a j omega. E power minus j omega t with the derivative and integral of this one, and apply again the integral of that one, j minus j omega, j omega. And for this also, minus b to minus e. Okay, my dear students. That's the first term. And the second here, plus b by b minus a. And here, directly I am taking the e power minus j omega t by minus j omega with the limitations of minus b to minus a. And here the third one is there, plus e power minus j omega t divided by minus j omega with the limitations of minus a and a. And for this fourth term, see the fourth term again I am applying here itself, plus take the 1 by a minus b is a common. 1 by a minus b. Okay. 1 by a minus b. Apply the integral of t into e power minus j omega t is a UV rule here also. T into e power minus j omega t by minus j omega with the values of here a to b, my dear students, a to b minus again the integral of derivative of this integral, and again you can apply the integral directly. I am applying 1 with e power minus j omega t with the 2 times integral minus j omega into minus j omega. The limitations is a to b. It's a fourth term. So first term, and it is a second term, and this one is a third term, and is a fourth. And last is we have the fifth one is there, my dear students here. What is a common term? Not the common, it is a constant term is minus b by a minus b with e power minus j omega t by minus j omega with limitations of a to b. Okay, my dear students. In this, substitute the minus a and the b, minus a and the minus b, and a minus a and b here. and A minus A and B to A and B to A and all the terms. Only we have the remaining these two terms only, my dear students. All will get cancels. All will get cancelled by whenever if you can take the e power j omega as a constant, e power j omega A and e power minus j omega A is a common term, you get the zeros. Okay. Finally, it having only these two terms only, my dear students. You can simplify that is equal to, the first I am taking here 1 by b minus a, 1 by b minus a. Carefully you have to write all the equations, my dear students. First of all, I am applying the upper limit here, minus a in this t and here also. Minus a, my dear students, minus a e power, here already the minus is there, minus into minus is a plus, j omega a, and in the denominator minus j omega is there, minus j omega is a one term. For the lower limit, here it is a minus, I am taking here the 1 by b minus a also again, 1 by b minus a for the second term. Now substitute the minus b as a t e power, here the minus into minus is a plus, j omega into b whole divided by minus j omega. Okay, my dear students. Here itself we will get the two terms. Minus, and this 1 by b minus a is also multiplied for this function. Okay. Minus 1 by b minus a whole multiplied with, see, minus j omega is minus j omega whole square is a denominator, minus j omega whole square. Okay, upper limit you can substitute. What we got is the upper limit, e power minus into minus is a plus, e power j omega a minus, and lower limit here, e power j omega b. What it, my dear students? And see the next, my dear students, here. We got the three terms, and for this, plus b by b minus a multiplied with, here also see the power minus j omega t, the minus a is the upper limit and minus b is the lower limit. Take it as the j omega a minus j omega b e power whole divided by minus j omega. Okay. And the remaining terms here, 1, 2, and 3. So observe here, one thing, 1 by b minus a into a is there, and here minus into minus b by b minus a, b by b minus a. Here the minus into minus is a plus, my dear students. Minus into minus is a plus, denominator is a b minus a, and here the minus j omega, e power plus j omega b. And here also you can observe here, b by b minus a, e power j omega b by minus j omega b. This is a minus term and this is a plus term. Why it is a plus term? Minus into minus is a plus here. And here minus term is there. So this term and this term it get cancelled. Okay, my dear students. In the same way, you can expand this term also. can expand this term and these three terms also. There is a cancellation occurs. After that, we have remaining only 1 by b minus a e power this term and whatever after expanding this. Okay, let us see that also. The next page. See for this e power minus j omega t, a and minus a and minus a to the a plus e power minus j omega a minus e power plus j omega a whole divided by minus j omega. Okay, my dear students. Okay, for this one time we'll get the minus, and by substituting the lower limit, minus into minus is a plus. Okay, my dear students, plus. Then for this 1 by a minus b. Remember here 1 by a minus b. See here the b minus a, b minus a, b minus a, b minus a. All you can convert these two terms also b minus a on. Okay, b minus a. So for this the b minus a, I'm changing the sign as a minus here. Minus 1 by b minus a, 1 by b minus a. See here, applying the upper limit and lower limit, b into e power minus j omega t, b into e power minus j omega b here, upper limit is b by minus j omega. Then here b minus a, I take the common, b minus a has the minus we got. Similarly for these also, b minus a means the minus term is there, minus into minus is a plus. Minus into minus, plus, my dear students, is a plus. The 1 by b minus a, 1 by b minus a, multiplying with, see the upper limit is a b and lower limit is a, e power minus j omega b minus e power minus j omega a whole divided by minus j omega whole square. Since in the denominator we have minus j omega whole square. And here the last term also, change this as a minus b as a b minus a. Already we have the minus b is there. So b by b minus a, the minus it get cancelled here, b by b minus a. Plus b by b minus a. See for this, here also the b by a, b and a is a limitations, e power minus j omega t, e power minus j omega b minus e power minus j omega a whole divided by minus j omega after simplifying, my dear students. Okay, is equal to, these are all the terms. I already told here minus into minus, b by minus into minus is a plus, my dear students. B by b minus a e power j omega b minus j omega. And observe here also b by b minus a, minus is there. Here the minus into minus is a plus, minus denominator minus j omega is there. So this term is get cancelled with this. Okay, my dear students. Now again observe here a by b minus a. Is there any factor is there? You can observe a by b minus a. There is no anything is a by b minus a. Forget about that. And b by b minus a e power j omega a, b by b minus a e power j omega a and whole divided by minus j omega for this also. B by b minus a. B by b minus a here. B by b minus a e power j omega plus e power plus j omega. There is no any plus j omega here. Okay. No plus j omega, my dear students. Only these two are get cancelled. B by b minus a e power j omega b by j omega, and here b by b minus a e power j omega b by minus j omega. And another thing, is there any minus terms is there? You can observe here. B by b minus a e power minus j omega b by minus j omega, and observe here b by b minus a e power minus j omega b minus j. It is a minus term is there here, my dear students, and this is a plus. So first term get cancelled. Alright, these two are get cancelled, and the remaining terms, see the e power j omega a by minus j omega, and here also see e power j omega by minus j omega. Both are positive only, exponentials. And here e power j omega a positive values. Three terms. And the remaining e power minus j omega a here, e power minus j omega is here, and the two terms. Okay, my dear students. Now you can simplify. Take this term minus a by b minus a minus a by b minus a and e power j omega by minus j omega, e power minus j omega by j omega a by, not the minus, my dear students, is a plus one. Is a plus by minus j omega is the first term remaining, and here 1 by b minus a minus j omega square. See, minus 1 by b minus a minus 1 by b minus a into j omega square means right directly. After that, we can simplify j omega minus j omega whole square whole multiply with e power j omega minus e power j omega b, e power j omega a minus e power j omega b, and the remaining term here b by b minus a plus b by b minus a into e power j omega a, e power j omega a whole divided by minus j omega. Okay, my dear students. And here, what is the remaining? The continuation, my dear students. Here the continuation. Here the terms is there. E power minus j omega plus e power minus j omega a by minus j omega minus e power plus j omega a by minus j omega, and here also you can see plus 1 by b minus a minus j omega whole square minus j omega whole square whole multiply with e power minus j omega b minus e power minus j omega a plus, here only this first term is get cancelled, plus b by b minus a into, here the minus term is there, my students, minus e power minus j omega a by minus j omega. Okay. Now, e power j omega a and e power j omega a and the term e power j omega a, take the common, minus a by b minus a plus b by a b minus a and minus 1 minus students. See, observe here, e power j omega a, I am taking the common, minus j omega. See, in the first term, there is a minus a by b minus a. And in this also e power plus a only. What is the common term here? It is a plus b by b minus a. And here the positive e power j minus a and minus 1. Okay, minus 1. Got it, my dear students? Then, another term we have plus e power minus j omega a, e power minus j omega a. See, for the remaining terms also will get cancelled. How? See, take the common here, b minus a plus b minus b and minus of minus plus e power j omega a by minus j omega. You see here, minus a plus b and LCM is a b minus a, the minus b, minus into minus is a plus a whole divided by b minus a. See, the bb get cancelled and a get cancelled, the term becomes a 0. So this term is get cancelled and this term is also get cancelled, this term and this term and this term also. Finally, we have these two terms only, my dear students. In these two terms also, what is a common term? 1 by b minus a minus j omega is a common term. Okay, finally, implies, okay, my dear students. See, actually here there is a 1 by b minus a b into e power minus j omega b by minus j omega, and in this here you observe here this is a term 1 by a minus b. So I take the common as a minus term is there, minus 1 by b minus a b I substituted, but the a is also there, a into e power minus j omega t. The one term is missed here, that is minus 1 by b minus a into e power minus j omega a by minus j omega. Okay, my dear friends. Now, in this also minus j omega a minus j omega, and these three terms we can take as a common. The three terms we get common. So e power, like I am taking the plus e power minus j omega a whole divided by minus j omega. Minus terms. You see, these are 1 and here minus b by b minus a, and because it is a minus term, why it is a minus term? It is a plus. A minus into minus, you'll get the plus because the lower term, and we are taking the minus is a common here. Minus into minus is a plus value, plus a by b minus a. Okay, my dear students. And the remaining these two terms, what is a common term here? Plus 1 by b minus a minus j omega whole square into, what is here? E power minus j omega a minus j omega b, and e power minus j omega b, and e power minus j omega a. The four terms. The first I am writing the two terms here. E power j omega a, here the minus term is there, minus, and here e power minus here. Take the total, it is a minus term. E power j omega a minus into minus here the plus, not the into, my dear students, a minus here the minus term, minus and the minus is a plus here, and the b minus a and minus. So e power plus j omega a plus e power minus j omega b. So minus e power, it is a minus term, students. It's not the power of minus. So let it be again, I will write whole multiply with, take the first term here, the plus value, minus is there, minus e power j omega a, and minus into minus is a plus e power j omega b, and here e power minus plus e power minus j omega b, and here the minus is there, minus e power j omega minus e power j omega a. Okay, my dear students. Now here also you can see plus the continuation I am writing, e power minus j omega a whole divided by minus j omega. Take the b minus a as a common. So b minus a minus b plus a whole divided by b minus a. So b get cancelled, a get cancelled, and b minus. So all the terms is get cancelled, my dear students. Only the remaining these two. What the finally, this term is a 0 and this term is also 0. B minus a by j omega whole square. You can write as j square is a minus 1, my dear students. Minus, j square is a minus. And if write it is a 1 by b minus a minus j omega whole square, and see here e power j omega b plus e power minus j omega b by 2. By 2 is a cos omega b. Means I am multiplying the 2 here. Minus e power j omega a plus e power minus j omega is a cos omega b, my dear students. Omega a. Understood? Now what is the final answer? 2 by b minus a. The j square is a minus, means it is a minus. So cos omega a minus cos omega b. Got it, my dear students? Take the screenshot. Total the 2 pages. Take the screenshots, my dear students, so then you can understand. Take the screenshot of the first one. And take the second, also the screenshot, and the remaining only, this is 0 and this is also 0. 2 by b minus a minus j omega whole square cos omega b minus cos omega a. And in this, j square is a minus. You can multiply this minus to this one. Cos omega a minus cos omega b will get the answer. Okay, my dear students. See whether it is right or wrong. You got the 2 by omega square b minus a cos omega a minus cos omega b. Got it, my dear students? Yesterday we got some ambiguity, and in the simplification, now you can see and take all of you can take the screenshot and practice this one. You'll get the answer, the 2 by omega square b minus a cos omega a minus cos omega b. Following, my dear students. And coming to the, already we've seen these two examples and this example also. And coming another example, the input of the input and the output of the stable and causal linear time invariant system are related by the differential equation d square y by y of t by dt square plus 6 into dy of t by dt plus 8y of t is equal to 2x of t minus 2. The differential equation is given. They're asking that to find the impulse response of this system. And second one, what is the response of the system if x of t is t into e power minus t mu of t? And a repeat part A for stable and causal linear time invariant system described by the equation. See, the given equation is this one. For the repeat part A for the stable and causal linear time invariant system, for this equation, differential equation, d square y of t by dt square and under root of dy by t dt plus y of t is equal to 2d square x of t by dt square minus 2x of t. Okay, my dear students. First of all, you see the first differential equation. What is the second derivative? Taking the Fourier transformation on both sides of the given differential equation, we obtain second derivative means j omega 1 by j omega, the j omega whole square, y of j omega 6 j omega into y of j omega plus 8 into y. The differential equation we know d by dt of x of t. The differentiation of time domain function, the Fourier transformation is j omega into x of omega or x of j omega minus 2. The square means j omega whole square. See, the derivative is the second derivative. J square is a minus omega square y of omega plus 6 j omega into y of omega and y 8 into y of omega is equal to 2 into x of omega. We already know that in the yesterday class I told the h of omega is a ratio between of output function to the input function. Output is a y and x is the input function. 2 by and y of omega you can take the common minus omega square plus 6 j omega plus 8. Okay, my dear students. Now I can find the factors of this one by using the minus b plus r minus square root of b square minus 4ac by 2a. Or using the calculator we can find the factors and partial fraction a by j omega plus 2 minus b by j omega plus 4. A is 1 and the b is minus 1 here. Now apply the inverse Fourier transformation 1 by a plus j omega e power minus 2t mu of t. And here the a is a 4 e power minus 4t mu of t. Okay, my dear student. This is to find the impulse response of this system. Impulse response of this system. And second one, what is the response of this system if x of t is equal to t into e power minus 2t mu of t. So instead of x of j omega, now what is it? T into e power minus t mu of t? Actually e power minus 2t mu of t, the Fourier transformation is 1 by 2 plus j omega. And it is a t is multiplied here, and the t is multiplied means it's a whole square. 2 plus j omega whole square. Okay, that you can take it as a multiplication factor of 2 into, that is equal to 2e by 2 plus j omega whole square. Now you can take the cross multiplication, that is a 2 by minus omega square plus j omega plus 8 into this one, 2 by plus j omega whole square. Again, by using the partial differentiation, with the two factors and here the two factors. Totally the order is a 4. So j omega plus 2 a by, and j omega plus 2 whole square b by, and j omega plus 2 c by whole cube, because the 3 terms is there. J omega plus 2 here, and here the j omega plus 2 whole square, whole cube, j omega plus 4. Understood, my students? And minus a, b, c, and the d. Finding this one, and apply the inverse Fourier transformation, 1 by 4 into a plus j omega e power minus 2 mu of t, and it is a whole square, 1 by 2 into t e power minus 2t mu of t, and the cube means that t is becomes of t square, my dear students. T square into e power minus 2t mu of t, and if it is a 4 means t cube. Okay, and minus 1 by 4 e power minus mu t, and what I am saying here, it is e power minus at mu of t. The Fourier transformation is 1 by a plus j omega. What happens when it is a t is multiplied, e power minus at mu of t, means it is a square of the function, 1 plus j omega whole square. See here the 1 is there, here the square. Okay, my dear students. 1 t power 1 whole power square here, and it is a cube, t square into e power minus at mu of t. What is a Fourier transformation? It becomes of cube, a plus j omega whole cube. So see the whole cube, it becomes of t square e power minus at. Following, my dear students. And the third one is the y of t. They are asking, what is the response of this system if x of t is changes? Okay, and third one, given the function is differential equation, for this one, second derivative minus omega square y of omega under root of j omega y of omega is equal to 2 minus 2 omega square x of omega minus 2 into x of omega. Okay, actually it is a j square. J square means a minus. So take all the components of y of omega and here of x of omega, and h of omega is ratio between of output by input, and find the roots here. We got the roots in the complex function, whatever it is a minus j omega or a plus j omega. For constant delta of t, inverse Fourier transformation, my dear students, not the Fourier transformation. Inverse Fourier transformation of 1 is delta of t. 2 into delta of t minus root 2, 1 plus 2j omega. Take the root 2 common here, 1 plus 2j, and it is in the form of 1 by minus common, you can take a minus j omega. So e power minus 1 plus j omega under root mu of t minus, and here also it is in the form of 1 by 1 minus a j omega. Okay, so like that, if any differential equation you can get, find the impulse response and find the response if any x of t is given, or to find out the h of omega is equal to output by the input. In this same example, we applied the Fourier transformation and we applied the inverse Fourier transformation also. Understood? Come to the next one. The same thing. Given the h of omega is given, You have to find out the h of t, h of omega. Find the factors here in the denominator. By using the partial differentiation, h of t we got. And also the x of t is given. H of t we got and x of t we got. Find out the x of t, the Fourier transformation. And they're asking that finding out the output response. What is the y of omega? X of omega into h of omega. X of omega we got and h of omega we got, and multiply these two functions. Multiply these two functions and apply the inverse Fourier transformation. Okay, determine the differential equation relating to the input x of t and the y of t of the s. Okay, my dear students. And the last topic, the very most last topic, suppose before going to the last topic, if you given any function, find the inverse Fourier transformation of x of omega is equal to, so very important, my dear students, it is omega square plus 21 by omega square plus 9. Suppose this is an example. Find the inverse Fourier transformation. Find the inverse Fourier transformation. See, upper numerator order and the denominator order both are the same. You can't apply the inverse Fourier transformation. Always you can see that numerator order is very less than the denominator order. If both are equal, you go for the division method. What is the division method? Omega square plus 9 is divided with, or that omega square plus 21 is divided with omega square plus 9. So one time, omega square plus 9, you take the subtraction, omega square and omega square get cancelled, 29 minus 9, 21 minus 9. What is it? 21 minus 9, it is of 12. Okay, my dear student. Now, the x of omega becomes 1 plus 12 by omega square plus 9. Okay, my dear student. Otherwise, you can see omega square plus 9 plus 12. The numerator of omega square plus 21. Now we can apply the inverse Fourier transformation. What is the inverse Fourier transformation of x of omega? X of t is equal to inverse Fourier transformation of 1 is a delta. Delta of t plus 12 is a constant. Now it is in the form of 1 by a plus is a 9, my dear students. A square plus omega square. A square plus omega square means it is a e power minus a the magnitude of t. What is the Fourier transformation, my dear students? 1 by a square plus omega square. Remember this one. So it is in the form of omega square plus 3 square. What is the value? E power minus 3 magnitude of t. The inverse Fourier transformation of the signal given the frequency x of omega is equal to omega square plus 21 by omega square plus 9. Okay, till now we did the some examples. The numerator is order is very much less than, not very much less than the denominator. It is easy way to apply the inverse Fourier transformation. Suppose it's both are the same, not at all equal, m not equal to n, the order. Suppose the m is the numerator order, n is the denominator order, m is very much, not very much, always less than the n order. Okay, then only can apply the inverse Fourier transformation of the Fourier transformation. Okay, my dear students. Now the last topic in the second unit, Hilbert transform. The Hilbert transform of x of t is defined by the h of t whole bar. You can see here the bar is there, represented as h of t. Hilbert transform is denoted by the cap. H of t cap is equal to 1 by pi. This varies from minus infinite to infinite. H of tau and the t minus tau theta. This is a formula for the Hilbert transform, my dear students. Okay, Hilbert transform. The inverse transform, the Hilbert transform by means of which the original signal x of t is covered from h of t cap is defined. So actually the h of t, the cap is a Hilbert transform. H of t is inverse Hilbert transform. So h of t is also the formula same. 1 by pi, the integral minus infinite to infinite, h of tau cap here. So h of tau is in the outside and the t and tau both are the same. T minus tau and the d tau. Understood, my dear students? So how, whenever if I am taking the x of omega is equal to, inside there is a x of t signal. Okay. Suppose if I am taking the x of t, what is the inside here? X of omega. It is with respect to the dt, it is with respect to the omega. Understood? But I am changing here the h of t whole bar. If any confusion is there, simply you can keep this as a tau. H of tau as an inverse Fourier transformation. Keep it as a t. And this is a tau minus t and the dt. Nothing is changed. Follow my dear students. The Hilbert transform defined as h of t cap is equal to 1 by pi integral minus infinite to infinite h of tau t minus tau d tau. Okay, my dear students. H of tau t minus tau d tau. Inverse Fourier transform. The function h of tau and h bar of tau are said to be a Hilbert transform pairs. What we read, the pair means x of t, the Fourier transformation, x of omega. In similar fashion, the h of t is a Fourier transformation of h of t bar. H of t, not the bar, h of t cap it is. Follow my dear students. Now what are the applications of the Hilbert transform? The applications here, areas of a signal processing, analysis and synthesis of signals, design of filters, etc. So this Hilbert transform is used in the signal processing, analysis and the synthesis of signals, design of filters, etc. to represent the band pass signals, to realize phase selective in the generation of SSB system, to relate the gain and the phase characteristics of their communication channels and filters of the minimum phase type. These are the applications, my dear students. And the properties also. And the properties of the Hilbert transform is a signal x of t or a h of t and its Hilbert transform h cap of t have the same amplitude spectrum, the same autocorrelation function. The energy spectral is same as for both x of t and x bar of t. Having the first property is for h of t and the h bar of t. Having the same properties, my dear students. I'm saying same amplitude spectrum. I will write in the whiteboard, my dear students, then you can understood. So properties of Hilbert transform. Take the screenshots, my dear students, after completion of writing all the properties. A signal x of t and its Hilbert transform not the x, it is a instead of x, you can take the h also. The h of t cap have first property saying that same amplitude spectrum. Both have it. Amplitude spectrum. And second point, same autocorrelation. Autocorrelation. See, this is a word until now we didn't have this autocorrelation. So the fourth unit you will get the correlation and the convolution and correlation. In that correlation is the two types. One is autocorrelation and the cross correlation. Correlated between the two signals. Same signals we are comparing, we can call it as a autocorrelation. Different signals we can compare and what are the relations are there in between, we can call it as a cross correlation. Same autocorrelation function. And third one, energy spectral density. Okay, these also will get in the fourth unit, my dear students. Not the fourth unit. Fourth unit for EEE students and third unit for the ECE students. Okay, energy spectral density is the same for both h of t and the h bar of t, h of t cap, and these two are orthogonal. H of t cap are orthogonal. Already we know the orthogonal means mutually perpendicular to each other. Orthogonal. Okay, my dear students. And the fifth one, the Hilbert transform. See what we are having, the Fourier transform of Hilbert transform of h of t cap is equal to, already this is a for Hilbert transform, and I am again applying the Hilbert transform, nothing but h of t cap and cap according to the involution law. We already know on the STLD, well known by the EEE students and the ECE students also. X bar whole bar is equal to x only. So h of t. And the sixth one, as if the Fourier transform exists, Hilbert transform also exists for energy and power signals. Hilbert transform also exists for energy and power signals. Okay, my dear friend. These are the properties for the Hilbert transform. You take the screenshots or you can write, take the notes, my dear students. A signal h of t and its Hilbert transform h cap of t have same amplitude spectrum, same autocorrelation function, and energy spectral density is the same for both h of t and h of t cap, and h of t, h cap t are orthogonal. The Hilbert transform of Hilbert transform is a normal function h of t, and as of the Fourier transform exists energy and power signals, Hilbert transform also exists for energy and power signals. Following, my dear friends, I already told the applications. You take this screenshot or you can note down this. And these are the applications, my dear students. Other important one you have to remember in the Hilbert transform. See what we are saying in the Fourier transformation. Fourier transform is converting time domain to the frequency domain. The one thing you have to remember in the Hilbert transform and the Fourier transform means one to the another. So actually the Fourier transform, or it is a Laplace transform, or it is a Z transform, converting time domain to the frequency domain. So x of t is a Fourier transformation you can apply. It becomes of x of omega, or x of t. We can apply the Fourier series. It becomes of frequency x of k. But h of t, whatever the signal, Hilbert transform, it becomes of h of t kappa. It is not in the frequency. It is also the time domain only. The Hilbert transform does not involve a domain change. Means time domain is not converted to the frequency. Time domain to the time domain only. The Hilbert transform does not involve a time domain change. The Hilbert transform of a signal h of t is another signal denoted by h cap of t is in the same domain only. Time domain, converting into the time domain only. It is not converting into the frequency domain, my dear students. And another one you have to note down, the Hilbert transform is not equivalent to the original signal. Why I am saying it is a one converted to the time domain means it is not similar. It is not similar what we are taking as a time domain or converting it to the Hilbert transform. It is also time domain, and both are not equivalent to the original signal. Rather than it is completely, it is a different signal. After applying the Hilbert transform to any of the signals, even if it is in the time domain, but it is a different signal. Okay. And in the Hilbert transform, the Hilbert transform on a signal is equivalent to a 90 degrees phase shift in all its frequency components. A 90 degrees phase shift will get after applying the Hilbert transform, my dear students. The Hilbert transform on a signal is equivalent to a 90 degrees phase shift in all its frequency, and only change in the Hilbert transform on a signal and is changing in its phase. Since the Hilbert transform changes cosine into sine, then we can say that it is orthogonal to each other, 90 degrees difference. Because in the one of the properties saying that h of t and h bar of t, h cap of t is a 90 degrees orthogonal to each other, mutually perpendicular means the Hilbert transform of the signal h of t, the signal h of t is orthogonal to the signal. Orthogonal to the signal. You remember all these terms as a Hilbert transform is a brief description about the Hilbert transform only. There is no need of taking off the examples on the Hilbert transform, my dear students. And 90 degrees phase shift is there. Hilbert transform introduce a 90 degrees phase shift. Carrying it out, it twice causes 180 degrees phase shift, which can cause a sign reversal. Of the original signal. If it is a 90 degrees, again it is a 90 degrees means for original signal the sign it is different. Plus becomes a minus and the minus becomes a plus, my dear students. Okay. So with this, the completion of all the topics covered in the second unit, Fourier series, Fourier transform, and the last, a brief description about the Hilbert transform, my dear students. Okay. And in the tomorrow class, we can start the third unit. And there is a difference is there, my dear students. For second year students, ECE students, as per the R19 syllabus, the third unit is not same as the third unit of the R16 the triple students. Okay, for R16 triple students, the sampling is there, and that sampling is half part in the third unit of the R19 syllabus. And another topic is also the added of the third unit for the R19 students for the EC. Anyhow, I will start in the tomorrow class the sampling. It's a very, very small unit it is, having only the 3 or 4 topics, but it's a very important topics. We'll complete the third unit of triple E students, but for the second year students, it will half part is completed only in the third unit. The remaining half part is included in the fourth unit of the triple E students of the third year, and you have the third unit only. That is a linear time invariant system. Linear time invariant system. Understood, my dear students? Any questions, please? Okay, thank you.